Good day, everyone. You're welcome to class. In this class, we'll be looking at a question under current electricity. The question says, calculate the terminal potential difference across a 20 ohm resistor connected to a battery of EMF 15 volts and internal resistance 5 ohms. Now, for us to solve this problem, it's important that we draw the circuits. Now, this is a simple circuit. According to the question, it is a 20 ohm resistor connected to a battery. So it's as simple as that. The symbol for a resistor is just something like this. So we have a resistor connected to a battery. A battery is series of cells. So let me just use two cells, and this is what it is. Now, this is our resistor, 20 ohms. 20 ohms resistor. This is the battery. The EMF is 15 volts. 15 volts. And we're told that the battery also has internal resistance of 5 ohms. Now, what do we understand by internal resistance? They are saying, in as much as a battery is the source of current, it also has an opposition to the flow of current internally, and that's because of the components, the properties of materials used to make it. Things like the electrodes, the electrolyte, they also bring about opposition to the flow of current. So that is what is being said in this question, and they give us the internal resistance of the battery. So now we have the load of 20 ohms connected with this. Now a battery, or it will definitely produce currents I. So we are asked to find the terminal potential difference across the 20 ohm. So we are looking for the potential difference from this point to this point. So let's target this, let's call it VR. That's what we are looking at. But for us to solve this problem, we need to understand all that is happening here. First and foremost, what is terminal potential difference? Terminal potential difference across 2 points is the work done in moving a charge from one point to another. So it's actually the work done by the charge to move from one point to another. Work done by the charge to move from this point to this point. That's what terminal potential difference is. But what is electromotive force? EMF. EMF is the total work done, and that is the work done by the cell or the battery in moving a unit positive charge across a circuit. So if you have like a battery and they write 1.5 volt on it, that is the EMF of the battery. Whatever voltage, that is volts, that's been written on that particular cell, that is the EMF of it. So in this case here, this is sometimes also called what? The voltage drop. So we want to find this. But now, this 20 ohms resistor, if we look at this current that flows through it, the same current that enters 20 ohm resistor will enter this 5 ohm resistance here. And when you have the same current flowing through components, now we say those components are connected in series. If we have resistors connected in series, to get the total resistance, so if we want to get the total resistance of resistors connected in series, so let's say this 20 ohms resistor is capital R, and this internal resistor is small letter r. So the total resistance in this case will be what? Capital R plus small letter r. So that being said, now we want to look at the relationship between this EMF and the current and the total resistance. But according to Ohm's law, now Ohm's law says that what? The current flowing through a metallic conductor is directly proportional to the potential difference applied between its end, provided temperature and other physical factors remains constant. So according to Ohm's law, it states that V is equals to IR. But in our case here, we are dealing with what? EMF. So EMF, which is also in voltage, V is in voltage. So we'll say the E now, which is also in voltage, is multiplied by I, is I multiplied by, instead of us writing R, we go with what? The total resistance, and that is R plus R. So this being said, let us substitute our given parameter to get our I. So E now, which is 15, is equals to I into bracket 20 plus 5. So 15 is equals to what? 25 current. I. So our I here, current in this case, is equals to 0.6 amps. Now that we know our current to be 0.6 amps, voltage across this 20 ohms resistor, and that is VR, is the current multiplied by the resistance. The current that we calculated, because it's the current that is flowing through it, 0.6 multiplied by the resistance, which is what, 20 ohms. And that 0.6 times 20 will give us 12 ohms. So that's the voltage terminal potential difference across the 20 ohms resistor. Till we meet next time, keep studying.